Hello. This week we're going to be working on ratios. So I want to kind of give you a preview of everything that we are going to be doing with ratios and just kind of jump right in. So first thing, in 7th grade, you guys are only dealing with proportional relationships. So when you look at one of the parts of our standards include graphing lines. And if you look at this line, it's not straight. It does start at the point of origin, that 0, 0. Look right here, at the 0, 0, but it's not a straight line. It's squiggly. So this tells you that it's not a proportional relationship. In order to be proportional, it must start at 0, 0, that point of origin right here, and be straight. So if we look at letter B, you can see this is a straight line, so I might think that that's proportional. But then when I look at where the line intersects, it's not intersecting at the 0, 0 mark here, where it must intersect right there and be straight in order for it to be proportional. So this one is not proportional. This one's starting a little bit higher. It looks like at 0, 4 instead of 0, 0. Letter C. You can see it intersects that 0, 0, that point of origin right here. It is a straight line. So this one right here is proportional. All you have to do when you're looking at graphs is ask yourself, does it hit the 0, 0? And is it straight? Boom, it is. So this one's proportional. Letter D, you can see it doesn't meet either of the requirements. It's not a straight line. It also does not intersect at the 0, 0 mark. Okay? So that when you're looking at graphs, you can easily tell if it's proportional. Proportional just means it's equivalent fractions. So if I flip this over, proportional is the same. Ratios are fractions, okay? Ratios can be written in 3 ways. You can write it as a fraction, 1 to 3, like that. You can write it with a semicolon, 1 to 3, or you could write it in words, 1 to 3. Okay, that's the 3 ways that you learned how to write ratios in 6th grade. You can do this however you want. However, I will tell you, oftentimes, writing it out as a fraction tends to be the way that 7th graders are most successful because you're really familiar with fractions. So if I asked you if this is proportional, if 1/3 is proportional to 2/6, you would just ask yourself, are these equivalent? 1/3, if I double the 3, it makes a 2. If I double my numerator, if I double the 3, it makes a 6. If I double the 1, it makes a 2. So these are equivalent. So that means they're proportional. Proportional. Okay, that means that they are increasing at the same rate. The x and the y, the numerator and the denominator, are increasing at the same rate. Okay? And if they increase at the same rate, if they're proportional, they start at 0 and they make a straight line when they're graphed. Okay, so that may not make total sense just yet, but it is important that you understand in order for a graph to be proportional, it needs to start at 0, 0, the point of origin, and be straight. Okay, it'll all come together in a bit, but that's the first thing you need to understand about graphs and ratios. Another piece that you're going to be working with in 7th grade are tables. And something that a lot of people don't realize when they start working with ratios, again, I told you these are fractions, so it's like this is 0 to 5, 1 over 10, 2 over 15. That's what these are. They're just fractions. But back in the day, when you were younger, you guys did input-outputs. So it was like this was the input-output table. And you had to figure out what was the rule to get from here to here. And if I look in this first one here, these are both zeros. which should sound familiar because x is 0, y is 0. That means that we're starting at that, if we were to graph it, we'd be starting at this 0, 0 point, that point of origin. Then we have 3 to 12. Think back to your input-output tables. In order to get from 3 to 12, we multiplied by 4. If this table is proportional, then all of these were multiplied by 4. So is 4 times 4 16? Yes. Is 10 times 4 40? Yes. So did we follow the same rule of multiplying by 4 throughout the whole table? Yes. So it's proportional. Okay, so again, just like with the graphs, it has to start with 0, 0. And we have to do the same thing to our x to make our y throughout the whole thing. You have to have the same rule. Okay? And in actuality, this rule is your unit rate. It means every time there's one x, we multiply it by 4 to make the y. Letter B, proportional relationships have to start at 0, 0, which this does. And then from here, 6 to 15, well, we're multiplying 6 times something to make 15. I can figure out what that is by doing 15 divided by 6. 6 goes into 15 twice, which makes 12, leaving me a 3. 0 would be next. And so we have a 2.5. So I'm multiplying by 2.5. Here, my 0 times 2.5 made 0. 6 times 2.5 makes 15. 8 times 2.5. So if I have 2.5 times 8, 40, 20, that makes 20. So that one's good. 19 times 2.5. 19 times 2.5. Oh, I might need myself more space here. 45, 18, 22, 0, 5, 2, 275 with 1 after the decimal. Oops, nope, 47. So this one is proportional because we multiplied each one of these by 2.5 to make the other. Same rule was followed throughout the whole table, and we started at 0, 0, so this is proportional. Here, the time in 0 hours, it cost $100 instead of $0, so this is not proportional, and I can tell right away, right here. Okay, so remember, graphs, to be proportional, must start at the 0, 0 mark and make a straight line. Tables also must start at the 0, 0 mark and must follow the same rule the whole way through. Okay, just like your input-output tables. Did we do the same thing to each number to make the other number? Okay. In other words, is 3/12, and another way to look at this, 3 over 12, is that equal to 4 over 16? That's what we're asking here. And if we simplify these, let's see how this is 3 to 12, 4 over 16. If we simplify these, we'd have 1 over 4. This is 1/4, and this is 1/4. These are all equivalent to each other, so they're proportional relationships. 10 over 40 is equivalent to these because it's also equivalent to 1/4, which is equal to this, which is equal to this. So again, proportional relationships are just equivalent fractions. Okay, so that's something you're super familiar with from all the years of working with fractions. So, okay, so don't worry about those. So you need to be able to tell if graphs are proportional.
David, please
if tables are proportional, and we also are going to be making lines or equations, linear equations from our ratios. Okay, so this was the intro to ratios. Hopefully you took some good notes to help you out, and I will have another video following this one. We out.